A very good morning. Now I'm going to discuss about evolution of IoT. Myself, Dr. N.A.S. Vinod, Assistant Professor, Department of Computing Technologies, School of Computing, SRMIST, Katankulattu. We look at the Internet of Things, where the word Internet, the word things. First we see what is Internet. As we all know very well, the Internet is a global network of computers connected together. With this internet, it is possible to access informations and also it is possible to communicate with anyone else. Comes to the things where the physical objects. So whatever the things that is objects present in the world, we'll be calling it as things here. So the Internet of Things is a network of physical objects or things embedded with electronics, softwares, sensors, and network connectivity. It enables these objects, that is these things, to collect and exchange data between them. So they can collect the data and they can possibly exchange the data between them. And it allows the objects to be sensed. It will be sensed and controlled. Can control remotely across in the existing network infrastructure. It creates an opportunities for more direct integration between the physical world and computer-based systems. It results in improved efficiency, accuracy, and which is more economically benefit. The IoT is everywhere. The saying IoT is everywhere. So this IoT, that is when the physical objects are embedded with sensors, software and other technologies for the purpose of connecting and exchanging the data or information, which is there in many things. If you look at this image where you can see a lot of things where the IoT is embedded. And this Internet of Things describes the devices with sensors. They can process themselves, that is they have the processing ability, and the software and other technologies. So these things were inbuilt in here. And if you look at this one, this where the IoT becomes increasingly essential for business operations. So where you can see IoT in the microwave oven, then air conditioner, and then in electric bulbs, computers, wherever, washing machine, whatever. So the things which we are using in our day-to-day life, which all comes with the IoT. So this IoT becomes increasingly essential for business operations. The need to deploy IoT applications everywhere puts greater emphasis on wireless connectivity of all types, which includes cellular, satellite, and Wi-Fi. There were numerous IoT constellations are now deployed or being deployed. And 5G rollout is putting cellular IoT on steroids. Private cellular networking is now hugely attractive for enterprises of IoT. And Wi-Fi has graduated to Wi-Fi 6 and soon Wi-Fi 7 will come. Comes to Internet of Things. The things in the IoT can sense, can refer to wide variety of devices, which includes health monitoring in plants, biochip transporters on farm animals, electric lamps in coastal waters, automobiles with built-in sensors, environmental food pathogen monitoring or field operations. These devices can collect the data which is useful with the help of various existing technologies and then autonomously flows the data between other devices. Comes to the IoT components. Here the IoT components were mentioned here. The first thing is sensors. The sensor to sense. The device has to sense. Then the connectivity. When the device sensing somewhere and we are controlling here. Some comes to the history of IoT. This history of IoT, where there are several examples of interconnected electronic devices exist as the early 19th century with the invention of the telegraph and its ability to transmit information by coded signal over distance, the origins of the IoT date to the date in late 1960s. Actually, it was then that a group of prominent researchers, they have started exploring the ways to connect the computers and systems. The prime example of this work was ARPANET, as we seen in the previous slide, the network created by the Advanced Research Projects Agency of the US Defense Department. And this network was a sign of today's Internet. In late 1970s, business, governments, and consumers, they started exploring the ways to connect personal computers and other machines to one another. In the late 1980s, LANs provided an effective and widely used way to communicate and share documents, data, and other information across a group of PCs in real time. By the mid-1990s, the Internet extended those capabilities globally, and researchers and technologists began exploring the ways that humans and machines could better connect with each other, with one another. In 1997, British technologist Kevin Ashton, co-founder of Auto ID Center at MIT, explored a technology framework, radio frequency identification, that is RFID, for physical devices. They allow the physical devices to connect via microchips and wireless signals. And it was in a speech in 1999 that Ashton coined the phrase Internet of Things. With a few years, smartphones, cloud computing, advancements in processing power, and improved software algorithms had created a framework for collecting, storing, processing, and sharing data in a more robust way. Sophisticated sensors appeared that could measure motion, temperature, moisture levels, wind direction, sound, light, images, vibrations, and numerous other conditions, along with the ability to pinpoint a person or a device through geolocation. And these developments made possibly the ability to communicate with both digital devices and physical objects in real-time scenario. For example, by adding a tracking chip, such as an Apple AirTag, to an object, such as a wallet or suitcase, it is actually possible to view its location. We can view its location. Here is a glimpse of history of IoT. Kevin Ashton, who introduced the term Internet of Things in the year 1999. In 1999, the Internet of Things was termed by Kevin Ashton. Later, in 2000, the company LG, who introduced the world's first refrigerator with internet. LG introduced the world's first internet-enabled fridge. Then in 2001, electronic power code, that is EPC, was proposed by David Brock. In 2002, ambient orb, named one of the ideas of the year, was launched. And in 2003, companies started using the term IoT SIM card in the place of MTM SIM card. Earlier it was mentioned it as MTM SIM card, and in 2003 we started using the term IoT SIM card. And 2004, in 2004 the RFID was deployed on a massive scale in the United States. In 2005, the Wi-Fi enabled Rabbit Nabastag was manufactured. In 2006, Vibri, a low power WLAN was introduced by Nokia, and in 2007 ISA 100 committee was given access to the wireless HAT standard by HCF. In 2008, the first European IoT conference was held. In 2009, Google started testing of Waymo, Google's self-driving cars. In 2010, Google Street View service could collect data as well as on Wi-Fi networks. 2011, IoT was added in the hype cycle. In 2012, one of the largest European tech conference, LE Web, was dedicated to IoT, where large number of researchers presented the research related to IoT. And in 2013, Google created smart Google classes. So this was smart Google classes we can wear and we can use. In 2014, Dublin became first IoT-based smart city, and in 2015, SG20 was created to address standardization requirement of IoT. In 2016, the first large-scale IoT-based attack took place on DYN servers. In 2017, Internet of Battlefield Things started as IoT entered in military applications. In 2018, IoT entered healthcare industry, where the healthcare technologies started evolving with the IoT devices, that is IoT sensors. Then in 2019, 5G became commercial with heavy deployment. We started using 5G, and in 2020, the focus shifts to IoT security, as more than 100 million attacks took place in the first half of 2019. So due to which the focus move on to the IoT security. Then later in 2001, 2021, 2022, in 2023, 24 and all, currently we have focused more